Okay, hello. I'm Liz Tanner. I'm the Professor of Biomedical Materials at Queen Mary. I'm head of the Centre for Sustainable Engineering, and also I'm the Senior Professor, not quite, but I'm the Administrative Senior Professor in Materials. So I'm going to talk to you about the degrees we do in Materials Science and Engineering at Queen Mary, University of London. And Queen Mary, in some ways, is a very old institution. In some ways, is very new. So on this campus, we had Queen Mary College, founded getting on for 150 years ago, in the very, or somewhat pompous Victorian style. It was founded to provide education to people from all backgrounds and promotes diversity as a place where people of all classes and conditions congregate. That's terribly pompous and Victorian, but actually it's true, because this is the promotion of diversity and people of all classes and conditions congregate still applies today. We have been very strong in outreach, first in family, etc., to come to university. We were joined to Westfield College in the 1980s. So Westfield was the first women's college of the University of London. So again, in terms of diversity, we've been involved in teaching women for 151 years. We have St. Bartholomew's Hospital Medical School. Barts is celebrating its 900th birthday this year, and it's the oldest hospital still functioning as a hospital. They have updated the building since 1123. And then the Royal London Hospital, just down the road from here. In fact, I was down there yesterday afternoon. And that's the oldest medical school. So this is why we say we're old, some major institutions, but we are new in terms of our equipment, our facilities. You can see a picture of one of our halls of residence. And we have a nice campus. In fact, we have a lovely campus. We are a campus university. We're the only campus university of the Russell Group. So you've probably heard about the Russell Group. These are the 24 top research active universities. So Oxford, Cambridge, Glasgow, all the ones you'd expect. There are 5 in London: Imperial, King's, LSE, Queen Mary, and UCL. Only 4 teach engineering, LSE being the London School of Economics, fairly obviously doesn't have any engineering degrees, and only 2 of those Russell groups teach materials, Imperial and us. We have a Platinum Award for public engagement. So we are actually always going out, telling people what we're doing here at Queen Mary. We're the top university in the country for social mobility. Queen Mary's had 9 Nobel Prize winners over the years that the Nobel Prize has been awarded. So we've got a huge range of public appreciation and understanding of what we do. So going from our strategy of 2030, our vision is to open the doors of opportunity. And we say we're dedicated to public good, generate new knowledge, challenging existing knowledge, and engage locally, nationally, and internationally to make a better world. So that's Queen Mary generally. So now let's look and see where materials fits. So here is the Queen Mary, 3 faculties, science and engineering, here in the middle. Let's get the nice. Right, I don't have a laser pointer. I don't know if the slide's going in the wrong direction. What is happening? Right. Laser pointer. So we're in the Faculty of Science and Engineering. My apologies for that, Michael. You might need to edit me panicking out. So within the school, we have 5 schools. We're in engineering, material science. Electronic engineering goes with computer science. In fact, just across the courtyard from here. And maths is down the road. So we're all very close. I said we're a campus university. And just beyond the maths building are our student halls of residence. So we have 8 major degree programs: aerospace, biomedical, chemical engineering, design, innovation, and creative engineering, known as DICE, materials science and engineering, which I'm going to talk to you about, mechanical, robotics, and sustainable energy engineering. So I said again, Queen Mary goes from the oldest to the newest. So in fact, the first aero department in the UK was here at Queen Mary on this site in East London. And if you think back to when planes first flew, starting teaching in 1907 was terribly early. We established the first materials department. All the other departments you will see were developed as metallurgy. So by being a materials department, we are very strong in the novel materials. We've also been innovative in teaching. The first undergraduate degree in biomaterials was established by Bill Bonfield in 1991. We do well, we continue to do well. So Professor Karen Hing, she was made professor only a few weeks ago. Her office is 3 behind me. She's engineered materials for bone growth. So what you can see here is a huge stamp, far too big to go on any envelope. Now, 2019, the Royal Mail launched 6 stamps to mark 50 years of innovation in British engineering. So the Raspberry Pi little computer, you may well have used yourselves. You've probably seen, many of you will have certainly heard of, if not traveled, on the Elizabeth Line trains. The boring tunnel for the Elizabeth Line was another stamp. But the 2 most expensive stamps were the biomedical engineering. One was the development of MRI, you know, the magnetic resonance imaging, and the other was this one. So this is a material that was made here on this site by Karen, and spin-off company launched. Karen says she's now at about 500,000 people have been treated with materials developed and made here. And Karen and our last conversation 10 minutes ago was about teaching and who was doing what modules and what lectures. So people who are doing really exciting research are also the ones who will be teaching you. And that's the interesting thing about coming to university, and even more so coming to a research leading university such as QM. One of our more senior members of staff is Sir Colin Humphreys. If you've used the Plessy augmented reality headsets, that's material Colin developed. And he has set up more companies. He has a graphene company. So again, exciting stuff. Lei Sui, whose office is 2 that way, developed the first single crystal perovskite optical fiber. Now, we've all been using optical fibers. That's what's probably sending most of the signal to you this evening. Coming down a wire. Well, not a wire, but an optical fiber. School of Engineering Materials Science has an excellent research reputation. Every 6, 7, 8 years, every academic in the UK is measured for their research activity. And in engineering at Queen Mary, our quality of research outputs was 2nd in the UK. Overall, we were 7th, and 99% of our research was classed as internationally excellent or world leading. but you're coming to learn. So you want to know what else we do. And of course, one of the important things is where will you go? What jobs will you get? So this is the complete university guide this year, came out a couple of months ago, and it ranked us on an overall score, entry standards, student satisfaction, research quality, and graduate prospects. And by, excuse me, and by graduate prospects, we were the top. So you'll notice that Cambridge and Imperial are below us. So is Oxford. So we were first for graduate prospects. We were fourth overall and fourth for research quality. So excellent research, and we're producing employable graduates, which I hope you will think important. We're a smallish school, engineering and materials science. We have 1,500 undergrads. We're very international. Over 60 countries are represented, and over a quarter of our undergraduates are female. And in materials, it's probably about 50%. Overall, we have over 200 members of staff, 103 of whom are academics. So you can see we have a really good staff-student ratio. And particularly in materials, we have much smaller classes. You will be known to your academics. So let's think, what's material science? Because I imagine many of you have some idea. And are thinking, what does it really mean? I suspect your school has probably not been very good, hasn't heard of material science. We know this problem. So material science is an interdisciplinary subject. So we look at the physics and chemistry of matter. So down to chemical and interatomic bonds, we start there. What is holding two atoms together? So if you try and stretch them, how does that control stiffness and strength? So we're down at that fundamental level, going through to engineering applications and how we make things. So we're working at every scale, from the atomic up to turbine blades, aeroplane wings. Now, modern society uses advanced materials. For example, lightweight composites allow faster, lighter vehicles. You may or may not have looked at how the fuel costs of planes have changed. But over the last 30 years, the fuel consumption per passenger mile has gone down to 2/3 of what it was. Why? The planes being made 20 years ago had metal wings. The planes nowadays have fiber composite wings, lighter for the same stiffness and strength. Same thing applies to cars. We develop optical fibers for telecommunications, silicon chips. So what do material scientists do? Well, we really study the structure and properties of materials and how they're made. So how can we make them? And we develop new materials and how to manufacture them. Because you need to think about how you develop material, but how can you make it cheaply, efficiently, so you use less fuel in the manufacture? Why might you want to study material science? Well, basically, experts are in high demand. There are many more materials jobs in the UK than materials graduates. It's an area where it is easy to find jobs. There are companies looking for materials graduates that they can't find. So you could work in the automobile industry. So here is a Red Bull car. And part of the engine of that was designed by one of our graduates. We could be thinking about renewable energy. Here we're looking at what happens when it rains on solar cells, what's being released. Aerospace, medical devices, electronic. Basically, if you think about it, engineers like to make things. Whether you're an aero engineer, or an electronic engineer making chips. You're all making something, but no engineer can make anything unless they have the material to make it from. So materials scientists, materials engineers are fundamental to every bit of engineering. If you're really not sure which bit of engineering to go into, materials is good because you could come up with the same degree, and the person who did a project next to you could be designing a Formula One car. You could be looking at developing a material to go into the human body. That level of exchange. The industry is valued at over £200 billion. So that's why materials. But why materials at QM? So as I said, we're the first university to establish materials science degrees. Everyone else started metallurgy. So we're very strong on novel materials. Here is one of the pictures I think is fabulous. That drop of water is actually only a couple of millimeters across, but the surface it's sitting on is super hydrophobic. So if you actually tilted that plate it's sitting on, it would just fall off. We're very strong on novel, small classes and friendly staff. We know all our students. It's a Russell group, and we're ethnically the most diverse of the Russell Group universities. We have excellent links to industry. We have a very strong industrial affiliates forum. So for our major projects, we have links. The industrial affiliates come in week 7 of each term. And we call week 7 not reading week, but skills and employability week. So we use that week to develop those skills that you don't get in the normal classes, but is what's going to make you really employable. CVs, going out into industry, talking to industrialists. So in one semester, they look at all the undergraduate project posters, the MSCs. We have an excellent research reputation. I said, we are one of the world's leading centers in materials, and in particular biomaterials. And you're taught by world-leading material scientists. And you'll learn about the newest developments in material science and engineering. We have nice facilities. I'm sorry you couldn't come here on Saturday. We were actually down here in G27. So these are oval tables with 2 computer screens at each end. So this means you can either log into your university site, or you can plug your own computer in and as a group, work on a problem, see what's going on. Here is the makerspace, which is another bit that's great to work in. So when you arrive, you get training to use the makerspace. And once you're trained, you can go in there and make things. So there they are, all in their lab coats, very elegantly steel cap toe boots, so you don't damage your toes if you do drop anything, but you can get on and make them. So why is that particularly important? It's particularly important because we are thinking about how you can make a material, use it. But also, if you're involved in Formula Student, and many of the materials students are very popular with Formula Student because they have the knowledge to use materials, develop materials, and a lot of other the student societies, Hyperlink and so on, will actually use the makerspace. Formula Student, in fact, have their own garage where they can build and work on their car. We've got mechanical testing facilities, cell culture labs. This is a new bit of research equipment, materials processing, chemical engineering, structural. We have fabulous electron microscopy suite. And so in your final year project, you may well get to use one of our high grade electron microscopes. The newest one is worth over £1 million. But if you're doing the right project, you could get to use it under very strict supervision, actually. There's a limit to how much damage you can do to an electron microscope, but you could easily be using that. That supervision will make sure that you get the best work out of it, the best images. So here is some of the gang. And hopefully they'll look friendly. But to give you an idea of the research quality, you've probably not heard of the Royal Academy of Engineering unless you've gone for one of their student fellowships, student scholarships. But we have 4 fellows. There are only 1,600 fellows in the UK, and there are 4 on this photo. Here is James Busfield, one of the world leading experts in rubber. Sir Colin Humphreys, I've already mentioned, and Colin has another spin-off company working with graphene. So Harry Badisha is developed the steel used in the Eurotunnel rails. So that steel he developed, and the wear of the Eurotunnel rails is 1/10 of the other rails around in the UK. Oh, and there's me. And in fact, both Sir Colin and Sir Harry are fellows of the Royal Society. You've certainly had of the Royal Society. Isaac Newton, Christopher Wren, Hooke, etc., down to, right, I've seen the note about A-level requirements, that will fit on later, okay? So they are fellows of the Royal Society. So down to Einstein, to Paul Nurse, and so on. In fact, the current president of the Royal Society was our principal. So now let's look and see what we see in different years. We changed all our degree programs a few years ago. So every student does 8 modules each year. In the first year, for the whole of engineering materials science, 7 of the 8 modules are common. The 8th module is either materials, chemical and biomedical, or is for mechanical and aero engineering. So the other thing we do is half of the year is only continuous assessment. So all these 8 modules has some coursework at least, but engineering design, exploring materials, and experimental design and practice are solely coursework assessed. So you only have 4 exams, 2 in January and 2 in April, May. So it's actually, and one of the things you're doing in a lot of these is you're working in groups. So to give you an idea, I run one of the sections within exploring materials. And we look at mechanically testing materials that could be used in joint replacements. So we go into the lab and you do some tests. It's up to you to analyze them. And last year, that module was assessed by, in your group, making a video, no more than 9 minutes. And so that was the marks for that video, with 20% of the module mark. I had fun sitting down, looking at all the videos. So we have a range of methods of assessing it. Written reports, oral presentations. If you think about it, when you talk to your parents, your guardians, whoever, and the older siblings you have who are working, and what do? Well, they do something and they tell people what they've done. So written reports, oral, video, posters are there so you can see in the future you've got the skills as to how to present what you've worked. Even if you go out of engineering, those skills will be useful elsewhere. We interview, do vivas, we have problem sheets. So this is one of our students. presenting her poster at one of the uh, industrial forum days, where she would have been talking to industrialists, many of whom were actually our graduates, so they could talk about a science, but also give careers advice, etc. How do we teach? Well, this is a sort of an example week. So you've got lectures. We also have a number of flipped classrooms learning. But then you'll note that every undergraduate has an advisor. And that's someone there to advise you from careers. Should you do module this or module that? Should you go and do a year in industry? What's the benefits? What's the advantages? What are the disadvantages? Through to crisis. We'll do some crisis and then send you to student counselling, but we have their support is there. You'll note that some of these are shaded. So the problem-solving classes, you won't do all three. You may be in group A, in which case you do it at 11 o'clock on a Monday. You could, another one of your friends could be in group C, in which case they'd be on Wednesday mornings. Again, labs, and in fact, the labs are both morning and afternoon, but then again, only certain weeks. You'll notice Wednesday afternoon is blocked out. Wednesday afternoon is blocked out because that's student union activities. So you may be doing Formula Student, which is very definitely an engineering type activity. Or you could be in the Bollywood Dancing Club. Or if you are an outstanding student in terms of sport, we actually have strong support. You could be competing in an inter-universities judo match, for example. Or you could be in the park playing around and having a nice fun time with your mates playing football. Anything in between. So you've got through the first year, now into the second year. We have, again, 8 modules, materials 4. You can see we've got a lot of materials 4. So we're thinking about the applications, biomedical sustainability, structure and properties. How do we get sustainable manufacture? Can we make things more efficiently? Therefore, the embedded CO2 of something. Yeah. Here's my mobile phone. How much energy did it take to make that phone in China, ship it round, progress, etc., etc.? How much CO2 was involved in getting this phone into my hand? So let's think how we can make it. Phase transformations is good fun. It's actually Sahari Badisha who teaches that module as the lead module organizer. Functional materials, materials to make chips and so on, and production and processing methodologies. Third year, you've got an integrated design project, possibly trying to do some modeling. Materials, how do they fail here? So you'll be embedded in a research group, and it's a quarter of your whole year. Then you do electrochemical energy, engineering and energy storage, catalysis, failure of materials, materials processing, and then you can choose. Do you want to get more into the economics, designing for a circular economy? Can you reuse? Your individual project is you're working with an academic and their group. It's you're developing your individual skills and your specialist skills, your group skills. So you can see there's a range of structures, drops for printing, composite structures for aerospace. So that group will be a mixture of materials scientists, materials engineers, and aero engineers. So you're learning to work across the disciplines, electronics from waste heat, you're working with mechanical engineers. If you stay on and do the MEng, it's half that year as a group project. And some of these ones are green transition, recycling, green processing, and carbonization, or low-cost innovation drinking water treatment, or a vacuum chamber for lifting and propulsive behavior blades. Then you have taught modules. You'll be doing those modules with MSc students. So you will choose 4 of these and some other options. We also give you 2 options. So you have the BEng, MEng option, and I'll talk about that in a minute. But we also, for each of those, you can do an industrial placement, a year in industry, so that your degree program will say material science with industrial experience. And it's 1 year in industry. We have an industrial experience manager who's supporting you through the application in the year. The tutor will be there to help you. So here you can see a couple of our then students working for Rolls-Royce. And what's so good about doing this is that it gets you to take what you've learned theoretically in the classroom, in the labs here, into industry. What does that theory mean? How does it happen in real engineering? Very often leads to a graduate job. And you can almost think about that year as a, well, the company works out whether you're the sort of person they'd like to have, which if you're nervous in interview is great. And you can also work out whether that's a company you'd like to work for. Because don't forget, a job is a two-way. It has to be a company, organization you'd like to work for, and that they want you to work for them. You'll notice this little line in here. All placements are paid. So it's great. You really get to know what is happening. It's a year when you're not increasing your loan, you're decreasing it. You can also do a year abroad. You cannot do industrial experience and a year abroad. So develop, understand what's happening, learn another language, etc., etc. So one of the things, this is an engineering degree. So you want to look as to whether you're going to be a chartered engineer. Now, I said that we have the BEng and the MEng. The BEng is the 3-year degree program. You have a project, and it's accredited for IEng. It's an incorporated engineer, and partly for CEng. The MEng, the 4-year, which is an enhanced undergraduate degree. So if you do the MEng, you stay on for another year. Your funding runs through because you are on an enhanced undergraduate degree. Now, the MEng is accredited to be a chartered engineer. And you may be wondering what on earth a chartered engineer is. I always think the Canadians have a much better explanation. My Canadian colleagues are PEng, not CEng. That is a professional engineer. So if you want me to do something about boilers, I know nothing about boilers. I'm an engineering technician. If you phone up British Gas, they'll say, we'll send you an engineer. But that's not a chartered engineer. That's an engineering technician. So a chartered engineer is professionally qualified, and you do a mixture of the academic, then you work for a few years, you write a report, you have an interview, and come and develop all the areas. So we have a huge industrial forum, this major expertise. These are companies that employ our graduates. So things like Rolls-Royce, BAE Systems, aviation are in the aerospace industry. We do have one of our materials graduates working in Rolls-Royce cars as well. She did come up for an industrial day, got sent by train, not by car. So then the big car companies, Ford, Unilever, in terms of producing materials. But then we get down to small companies. Subaru is a Queen Mary spin-off. Some of our PhD students developed a better adhesive and they spun off. They're still headquarters in Hackney. So it's every sort of size. We've got a lot of medical. Matt Ortho, Baxter Healthcare, brought up the company set up based on Karen Hing's early work. And Karen still collaborates with them. So our graduates are all around the place. Big companies, small companies. You'll see both McLaren and Williams Racing, Formula One teams. Those are there because they are, so I said, James is a great expert on rubber. And a lot of his former students are working in the car tires part of McLaren Williams and of course Bridgestone. So, and now the last slide. Questions? You can drop me an email. I can see some questions. Right, I can see what's come up, which is what are our graduate requirements? I never answer that directly. Look on the university website. It will define it absolutely accurately. Now, for any engineering degree program, we expect you to have maths. Not because you have to love maths, but you have to use maths as a skill. So maths is one of the skills as engineers we use. What are we calculating? What's the airflow over an airplane wing, etc. Now, what we do have, of course, is, I said we have students from many parts of the world. And there is a part of the university website, if you go in, that will tell you how to translate whatever your country is. So if you look in the website, we'll now go back to what Michael said. So there is, if you go into the main Queen Mary website, you can see our undergraduate degree programs. Click on any of those, that will absolutely give you the entry requirements. And you'll notice that things like aero and mechanical are slightly higher. You'll note that the B-Eng needs lower grades than the M-Eng. That does not matter. As a B-Eng student, if you're doing well, you can transfer to the M-Eng. As an M-Eng student, if you're not doing well, we will move you to B-Eng. But there will be, so it doesn't matter. Apply for B-Eng or M-Eng. The only thing not to do is apply for the B-Eng and the M-Eng, because then you're using two of your UCAS options for one university. So that's some of the questions. Okay, I'm looking at what's in here. So that was the entry requirements. There is part of the university website. If you go in and start looking at applying to do materials, in a very long scroll down to the bottom is international students and international qualifications. One of the things to note is that if you are in certain countries like the US, China, India, Pakistan, Queen Mary has staff in those countries that are there to help people apply and get into QM. So again, look on the website. It's anything there. Right. What else? So the answer questions, scholarships. Yep, we've got that. So look in School of Engineering Materials Science, International Baccalaureate, we have a known requirement. Other countries we talked about. The anonymous person who wants to know about 7 in the International Baccalaureate. I don't know the expertise. Hopefully Michael will type you an answer. We do have a foundation program. So if you haven't quite got the A levels in terms of either grade or subject, we have both a UK and an international foundation year with entry into materials and some of the other engineering sites. I'm not sure about foundation in different years. I think that might be one of the ones that if you email SEMS admissions with exactly what you are, what are your questions, etc., they will go and find out the answer, because it may not be one of those, oh, the answer is instantaneously. They will check and get back to you. The person who's asked about the M-Engine placement year, yes, you can do, if I go back a couple of slides, if you notice here on the industrial placement, if you are doing the B-Eng, you can do it after year 2 or year 3. If you're doing the M-Eng, you can do it after years 2, 3, or 4. Now you'll notice that the 3rd year of the B-Eng and the 4th year of the M-Eng are normally considered to be your final year. So you do your year, you do your project, you do your final exams, but you don't graduate. You then go and do your year in industry and graduate a year later. So that has an advantage, is that if the company really likes you, they can offer you a job to start instantaneously. Yeah, you've done your year. When would you like to start work? Next week or the week after? Almost could be the question asked. So yes, M-Eng and in placement, industrial placement is very clear. How are we doing? Okay, biomedical engineering. This is not the biomedical engineering module. This is materials. But I teach on the biomedical engineering degree program, so I can answer that. So the intake for biomedical engineering, you have to have a maths degree, a maths A level, like any other engineering. But whether you've done physics or chemistry or biology as the other two, or you might be clever in doing 4 A levels, that's less defined. And I will tell you that I develop materials going to the human body. I work with orthopedic surgeons. I've been visiting professor in the orthopedic department in one of the Swedish universities. And I don't even have an O level, what's now called a GCSE in biology. So you learn the bits of biology that you need. Now, one of the things that I find is that many people ask me, but I've done maths, physics, chemistry, and the person at the next desk to me has done maths, physics, biology, but we've got different knowledge. What you'll see is that you do modules. Now, some of the modules, if you've done biology A level, will be easier, but others will be easier for the person with chemistry A level. So over the whole year, it will make no difference. You will have to do more background reading in one area than in the other. Does that make sense to the person who's asked about Biomed Eng and Physics A level? They're more coming down. What's maths like in this degree? The answer is that as I said, we use maths as a tool. And so in that first year, not first year, get back to the first year modules. This one, computational maths modeling, is that we don't do maths because we want to do maths. We do the maths that you're going to need to do your calculation for differential equations, partial differential equations. If you're thinking about analyzing flow down a pipe, or we're thinking about stress and deformation in an aircraft wing, those are all using equations. Those are what we're going to do. So it's very much more like applied than pure maths, because it's the usage. Does that help? Recordings for webinars. I hope Michael will answer that, because he knows where they are and I don't. Any others coming through? So let's just check these. As you see, I've got two screens. One of the things I would say, Queen Mary actually is good on scholarships. And particularly if you're a local, I suspect most people today are from all around the world, but it's got a very good range of scholarships to support people. And one of the things I was surprised to notice recently is that actually we have support for top class athletes. So and I will tell you that while I've been at materials at Queen Mary, two of our graduates have had Olympic trials, and I will tell you that they are both hold PhDs now. So Dr. Colin Rattigan did long jump and bobsleigh, and so did summer and winter Olympics. And Dr. Isaiah Adekunambi got trials for the London Olympics, and sadly got injured, so he didn't get them. But these are guys that got firsts, but the support that Queen Mary has for athletes is getting, it's nothing like the American, but we're starting to get, and we know that we've got good sports facilities. If you go up to the top of the building, just, I can see out of the window there, you can actually see over to the London Olympic Park. Material Science Foundation program, yep. Michael's put up the international link. Admissions tutors like to see in a candidate's personal statement. I would say, what makes you think you want, and this applies to whatever degree, what you're trying to sell yourself to us, the academics, is why do you have a burning desire to do this subject? What made you think about it? Did something happen? So it's what will make you feel like a good, interesting person to talk about. What it's different. I don't know if that helps at all. How to stand up from other candidates. What have you done? Have you gone and looked at something? Have you made something? I was talking about to potential candidates to do the design and innovation, design, innovative and creative engineering dice. What have you made? Why did you realize you'd suddenly used an interesting material? Those sorts of things will work well. Are we getting any other questions coming in? Michael, do you think we're doing quite well? You're typing hard again.
Yes, that's hello everybody. Hello Liz. Yes, been trying to answer your questions as they come in. I think it's a good opportunity actually for me to reiterate some of the questions that come in for everyone to have a little look at, because I think these apply to a number of you on the call. There's been a few questions related to overseas entry criteria, particularly for qualifications which are not necessarily listed on our course page. So there is actually a link on our website under the sort of international student section, which helps you understand what your qualifications are if they're from another country. So I suggest having a little look there, because it will give you an indication of how your qualifications for your home country compares to the A levels that we offer here in the UK. And therefore it can give you a good understanding of what you will need to study these programs. Of course, if you're still concerned, you can contact our admissions team who can give you further advice about that. There's been some questions related to being able to do a year abroad or a work placement on the BEng and MEng programs. These are an option. You can do either a year abroad, or you can do what we describe as a year in industry, and we will support you with finding those placements and that year in industry when you join the university. So you can make that application with year abroad or year in the industry on your application if you wish to do so. But it is one or the other. You can't actually do both a year abroad and a year in industry.
We need to get them to graduate at some stage, don't we, Michael?
Yes, yes. I mean, if you obviously wanted to continue your studies, there are further study opportunities, and that may actually take you abroad in the future. So you know, you don't need to do everything completely during your undergraduate studies. And there's also been a few questions about the foundation year, which I think for some of you, this is the first time you've heard about the foundation year. So it's no surprise that it's conjured up further questions. So what is the foundation year? So we have, as you've seen on our website, we have an entry criteria, ABB, which is from A levels to include maths, chemistry, or physics within there. So it's not all of them, but we do expect one of those to appear within, so two of those to appear within your ABB entry criteria. If you don't meet that entry criteria, then you can be considered with BBB onto an additional year, which we call the foundation year. And on successful completion of that year, you would progress into the full 3-year degree program. So this does mean, yes, you would be studying for a further year. However, you know, from my experience and the students I speak to, although they had concerns prior to coming to university about doing an extra year, what they've actually told me it's been very, very helpful, because it's given them the space not just to sort of you know, really work on their skills, particularly in areas of physics and maths, but it's also given them that chance to really get into the school, get to understand the subject area prior to actually following the full degree program. And actually 4 years, as you discover when you become a student, although it sounds like an awful long time at this stage, it actually goes incredibly fast. So I think the message is, don't be concerned if that's a route you think is more appropriate to go down. That's perfectly fine. So
Michael, we've got a hand raised from Ahmed Adil.
Okay. Did you want to type your question? Let's see if it's come up on the thing. It hasn't, has it? We can't take questions over microphones, but if you want to write that question, please do write the question into the chat box. We've had a question here with relation to, can we accept a foundation from another university? I will double check this with our admissions tutors. It's in my understanding that for some universities we can. Liz might be able to
No, I don't know the
No,
answer.
that's absolutely fine. So
That's one I can absolutely guarantee. Um, um, that I don't know the answer to. That is getting into the fine details. That is definitely send an email to SEMS Admissions, who will ask Central Admissions, because that is a complicated answer. Now, someone suggested Mark Miodovnik's Stuff Matters, alternative books. Very good comment, very good suggestion. Yes, Mark's book is really good. And that will give you a good feel for materials. The other thing I would say, and I've just realized, if I stop showing that slide, stop sharing, and that there's also a really good access if you're just going to open up another talk.
while we're waiting for Liz to have a little look there was a question about where can we review the recordings of these sessions. There's actually 8 different talks going on, so it'd be a great opportunity for you to have a look at these. We're going to be sending out a link where
Are you now
can
seeing a useful background reading slide, Michael?
I am, yes.
Right, so Ingenia is the Royal Academy of Engineering's house magazine. I really do call it. So it's for fellows and for schools. And if I just stand up, here is one of the issues. This seems to be quite an old one. I have a pile of them sitting there on my desk. But if you go to ingenia.org.uk, and if you live in the UK, you can get it by post for free every quarter, or you can get it sent online. So here we are. That's an interview with a head of Saudi Aramco. How do you make the horses for Warhorse, the actual war puppets? How do we talk to an engineer talking about their opinion where things should go? So that's well worth signing up for. It's free. And so the website there is, or you can see it, www.ingenia. And that's another really good, useful one to look at, if that helps. And that is for any sort of engineering. Any other questions coming through?
Well, I think we've just hit 6 o'clock, so I'm going to say, unless we get a question appear immediately, that brings today's talk to an end. Just to finish off what I was mentioning about the recordings, you will receive an email with a link where you can register to review all of the webinar sessions that we've been delivering on all our subjects, and absolutely. You know, if you still got some questions, we'll feel free to contact us directly. We have an email address which is SEMS, so SEMS, or School of Engineering and Materials Science. So SEMS dash outreach at qmul.ac.uk.
And there's SEMS Admissions that was on my slides as well.
And SEMS Admissions, and we'll try and get those answers to you. I hope you found this afternoon's session helpful. Thank you for joining the session. I know it's been a lovely evening, a lovely warm October evening. So we do appreciate that you've spent an hour with us at Queen Mary University.
You and I are on different floors, but I think we've got the same view out to a rather pleasant evening.
It is lovely here.
Sunny evening outside. So So,
Great.
so
Well, I will stop the recording there, and
mhm.
thank you again.
Okay, everyone, and hopefully